All right, here we go. Proof number 5, which means there's 4 more left to go. So here we go. We have proof number 5. So what do we have to prove? What in the world do we have to prove it with? So we want to prove that DB bisects ABC. Now we're getting complicated. Hold on now. So we want to prove DB bisects the angle ABC. So let's figure this out. DB is actually a line segment. I'm going to highlight in purple. We want to prove that it bisects the angle ABC. So that's actually going to be, and again, I'm marking in purple highlight. Um, so we're trying to prove that this angle has been bisected. Well, what in the world does that even mean? I'm going to go ahead and start kind of building our visualization. If I want to prove that DB bisects angle ABC, well, to do that, I actually have to prove that angle 5 is congruent to angle 6. And that's because that's a definition of bisection. If something's been bisected, that means the angles are congruent. So the angles are congruent, that means the angle's been bisected. Okay, so if I have to prove angle 5 and angle 6 are congruent, well, how in the world do I do that? Well, look what we've been given. We've been given a lot of information here. We know that BD is a ray. We know that AD is congruent to CD, so AD congruent to CD. And we know that angle 3 is congruent to angle 4. Wait a minute. If angle 3 is congruent to angle 4, I bet 1 and 2 are congruent. And I bet, if we think about it, that would have to be congruent as well. I think if we want to prove 5 and 6 are congruent, we again have to look at the big picture. If we look at this 5 and 6 as being part of bigger triangles, again, I think this reduces to simply proving the orange and blue triangles are congruent, because those triangles are congruent, then my angles have to be. So again, kind of building our plan, if we prove triangle ABD is congruent to triangle CBD, that would mean the angles are congruent. If the angles are congruent, then that big angle ABC has been bisected. So the question now is, well, how do I prove those triangles are actually congruent? If I look at the information I've been given, I think I can pull off side, angle, side. So again, kind of writing our plan out. Side, angle, side. Well, let's see. Side 1 was actually given to us in our original statement. So I can prove like AD congruent to CD because it's been given. The angles are going to be trickier, and I'm looking at the angles because they actually told us 3 and 4 are congruent, but we need 1 and 2 to be congruent, which if you look at the structure of BD, it being a ray, that forms a line with angle 1 and 3, which means I can probably get angle 1 to be congruent to angle 2 using some form of linear pair posture. Remember, this is a rough draft. There's probably going to be some more substeps to that, but that's going to be generally how I'm going to prove it. And S2, well, that's going to be reflexive. So if I have DB congruent to DB, that's going to be reflexive. Okay, so I think we have a solid plan here. I'm going to use side angle side to prove the triangles are congruent. The triangles will tell us angle 5 and angle 6 are congruent. If angle 5 and angle 6 are congruent, that means BD bisects ABC. So let's get to it. Let's prove these triangles are congruent using side angle side. So I think the choice I want to make here is actually going to be a 2-column proof. So let's go ahead and write in our 2 columns, or draw in our 2 columns, I should say. And again, the left-hand side as standard is going to be our statement. And the right-hand side will be our justifications. Okay, so we wrote a good plan. Let's stick to the plan. Like, that's the best thing we can possibly do at this point in time. So we're going to prove the triangles are congruent by using side angle side. Fair enough. Let's get to it. The first statement I have here says that AD and CD are given. Again, I want to point out that's actually in our given statement, so that's not a false one. So AD congruent to CD. The justification I can give is that it's been given to us. And again, just because I want to track my work, I'm going to put a little bracket out here and indicate I've just now proven side 1. And since I have the digital power to do so, I'm going to change colors. So let's work on this angle. Okay. So we have to use a linear pair postulate, but that's not going to be the end of the road. And again, what we're dealing with is we really need angle 1 and angle 2. Like we really need these two angles to be congruent. But we're given 3 and 4 were, so that's really where we need to start out. So let's start with our given, which is always a good idea. Angle 3 is congruent to angle 4, because that's been given to us. Okay. Because angle 3 and 4 are congruent, I can immediately conclude that the measurement of angle 3 equals a measurement of angle 4. And I know that because that's a definition of congruency. Now, you may be asking yourselves, why in the world did I do that? Like, why did I bring it all the way down to a measurement? We need 1 and 2, Mr. Collins. Why are you talking about the measurements of 3 and 4? Stick with me. I think you're going to see why here in a second. So we said we needed to start with linear pair postulate. Let's go ahead and bring that in now. Angle 1 and angle 3 are supplementary. And I can also claim at the same time angle 4 and angle 2 are supplementary. There's no point writing a separate step for this. They both conclude supplementary, so let's put them in the same step. And that's going to be directly because of linear pair postulate. Again, we got to start with structure. Well, check this out. If angle 1 and angle 3 are supplementary, and angle 4 and angle 2 are supplementary, that means I can start writing some nice measurement equations, like the measurement of angle 1 plus the measurement of angle 3 equals 180 degrees. In the same way, the measurement of angle 4 plus the measurement of angle 2 also equals 180 degrees. And that's going to be directly because of the definition of supplementary. Okay. So in step 4, I concluded they're supplementary. Because they're supplementary, in step 5, I can say they equal 180 degrees. Okay. So let's talk about step 6. Well, if I have, and I'm going to underline in orange, if this equation is equal to 180, and 180 is the same as this little expression, I certainly should be able to claim those expressions are the same expression. So a measurement of angle 1 plus a measurement of angle 3 is the same as or equal to measurement of angle 4 plus a measurement of angle 2. So we're really close. If we review our plan, we were trying to get angle 1 and angle 2 to be congruent. Right now, I have angle 1 and angle 2 on opposite sides of the equation. What I really need to do now is to get rid of 3 and 4. Well, right now that we're kind of at a non-start position because, well, 3 and 4 aren't the same thing, so to speak. But if you remember that weird step 3 I threw in, where I said I made the measure of angle 3 the same as measure of angle 4, here's where it comes into play. Look what I can do next. I can actually substitute one for the other. I can take out the measurement of angle 4 and replace it directly with the measurement of angle 3 because they are the same. And if you're wondering why they're the same, again, look at step 3. Step 3 has concluded that because the definition of congruency, that since they're congruent, the measurements are the same. And since the measurements are the same, I can substitute. I'm sorry, I'm back when that was transition. And then step 7 is going to be substitution. Okay. So if now I have measurement angle 3 on both sides of the equation, I can immediately say that measurement angle 1 is equal to the measurement angle 2 because I'm subtracting or solving out. I'm just going to put subtraction here. Usually we just say solving, but since this is definitely just subtraction, I'm going to do that. Hold on, give me one moment. I'm going to shrink this because I need some more room. I'm going to try to shrink this. Okay. Yay, notability. Okay, so that's going to be subtraction. So let's kind of finish this up here. If measure of angle 1 is equal to the measure of angle 2, that means angle 1 should be congruent to angle 2. And the justification is because that's the definition of congruency. That's what it actually means to be congruent. So that was all simply to prove our other angle. Review our steps. We said we're going to prove the triangle is congruent by SAS. Congruent triangles give us congruent angles. Angles give us bisector, which is what we needed. So all of that was necessary to prove the angles are congruent. Because again, we can't leave any steps out. We can't skip any steps. That's as many steps as it actually takes. So we are now finally to our third side. This one I think is going to be a little bit faster because it's just a reflexive property. So September proof, we can claim that BD is congruent to, let's check it out, BD is reflexive, of course. Okay, so that's going to be this reflective property. So again, what we're talking about in these triangles, we've now proven side 1, and I'm going to squiggly these in green. So we've now proven side 1 is congruent to side 1. Proved it right there. We've now shown that angle 1 is congruent to angle 2, that step. And then we just have now shown that reflexive gives us that. So all the angles, all in the triangle are congruent. I'm sorry. We've now met the conditions for congruence, I should say. Okay, so we now met the conditions for congruency, so let's go ahead and write in our triangles being congruent. Okay, so step 11, triangle ABD is congruent to triangle CBD. And that's going to be because of the definition. Oh, not the definition. Let me talk about Mr. Collins. We've just carefully shown that we have side angle side. So the justification for this is going to be the side angle side triangle congruence theorem. Okay. So we're pretty darn close to the end. So if we're kind of, again, if we're reviewing our plan, which we should always go back and review our plan, we said we're going to use side angle side to prove the triangles are congruent, which we just did. We're going to use triangle congruency to conclude the side lengths, or I'm sorry, the angles, and because the angles are congruent, then it's bisection. So we're actually just about 3 steps to the end here. So if the triangles are congruent, okay, that means in step 11, I can say angle 5 is congruent to angle 6, because if the triangles are congruent, that should be step 12, then all the corresponding angles and sides are congruent. So the justification here is CPCTC. Corresponding parts of congruent triangles are congruent. And then in step 13, if those angles are congruent, that means BD is a bisector of angle ABC. And that's going to be because of the definition of bisector. And again, you'll note that definitions are biconditional. Do that are biconditional by their very nature. And that is our proof. That was quite a long one, but you'll find this you're getting a better sense of how proofs are actually used. So like triangle congruency is boring. It's what you can do after you know the triangles are congruent. That's really important. Okay, so let's review. We wanted to prove 5 and 6 with 5. I'm sorry. We wanted to prove that BD is a bisector of angle ABC, which is comprised of angle 5 and 6. So we determined if I can prove angle 5 and 6 are congruent. Again, in terms of highlighting, if I can prove these are congruent, that means those have to be bisected. Okay. The way I'm going to prove congruency is by proving the triangles are congruent, which we're given enough information for side angle side. So by using side angle side, my triangles are congruent. Triangles are congruent mean my angles are congruent. Angles are congruent means that BD bisects a triangle ABC, and bam, there is proof number 5.